The last individual transformation that we're going to look at is a dilation. So if you remember, dilation is a transformation where you change the size but not the shape. You either blow it up, you make it bigger, or you shrink it, you make it smaller. Okay? Remember, what you're left with is similar figures where the sides are proportional and the angles are congruent. All right, now one thing we'll be looking for when we're talking about dilations is our scale factor. And the scale factor, or that linear scale factor, is the ratio of a side length of the image to the corresponding side length of the pre-image. All right, K represents that scale factor. So that's what K is going to that's what K is going to represent. All right, so to find K, we're going to take a prime distance over a pre-image distance. Okay, so if that K value is in between 0 and 1, that's going to be shrinking something. So the image is going to be a reduction. Okay, we're getting smaller. If our K value is bigger than 1, that image is going to be an enlargement. Which means that our image is going to be getting bigger. All right, now, in order to find our K value, make sure you write this down. We're going to use the prime distance over the pre-image distance. So, in example 1, let's determine whether or not the dilation is a reduction or an enlargement, and then find the scale factor. All right, so in example 1a, we've got this big rectangle, ABCD, and then this tiny rectangle, A prime, B prime, C prime, D prime. So that is a reduction. That's getting smaller there. Okay, now we need to find the linear scale factor. So prime over pre. So C prime over B, or C prime B prime is 2 units. So I'm going to find my K value. I'm going to check C prime B prime over CB. So C prime B prime is 2. CB is 1, 2, 3, 4. 2 over 4. Which simplifies to 1/2. So it's a reduction. My K value, or my scale factor, is 1/2. Which means that A prime, B prime, C prime, D prime is half the size of its pre-image rectangle ABCD. What about B? Well, we start with HEFJ. What did I just say? HEFG, sorry. And it gets bigger to H prime, E prime, F prime, and G prime. All right? So this is an enlargement. Okay? HG and H prime, G prime. That's what I'm going to use. So I'm going to compare prime to pre. H prime, G prime is 1, 2, 3, 4, 5, 6, 7, 8, 9. And HG is 1, 2, 3. So 9 divided by 3 is 3. So my K value is 3. H prime, G prime, F prime, E prime is 3 times as big as HGFE. That's what that means. That's what that K value means. Okay? So, in example 2, the vertices of triangle ABC are given. So let me plot these real quick. You do the same. B is at 0, 6. C is at 3, 6. All right, use scalar multiplication to find A prime, B prime, C prime after a dilation with its center at the origin. So that's a key part here. We're centered at the origin in the scale factor of 1/3. Graph ABC in its image. Okay, so I already graphed ABC. Now, our center of dilation is the origin. So what I'm going to do here is I'm going to manipulate how I move from the center of dilation to a point. Now, what I mean by that is, okay, my center is the origin. What do I do to get to A? I go 1, 2, 3 to the left. All right, but my K value is a third. So what's a third of 3 to the left? That's only going to be 1 to the left. So A prime is going to be -1, 0. In order to get to B from my center of dilation, I'm going to go up 1, 2, 3, 4, 5, 6. What's a third of 6? Instead of going up 6, a third of 6 is 2. I'm only going to go up 2. So there's B prime. So B prime is 0, 2. And lastly, to get to C, my slope, I'm going to go up 6 over 3. Up 6 over 3. So instead of going up 6, a third of 6 is 2. So I'm only going to go up 2. Instead of going to the right 3, a third of 3 is 1. So I'm going to go up 2 to the right 1. That's C prime. So there is the image of this triangle. The coordinates C prime are 1, 2. Now, you might notice a pattern here. Look at the pre-image coordinates and look at the image coordinates. -3, 0 went to -1, 0. 0, 6 went to 0, 2. And 3, 6 went to 1, 2. All right? What did we do? Well, because it was centered at the origin, all I had to do was take my coordinates and I had to multiply them by my scale factor. Okay? So because it was centered at the origin, and we'll get to an example in a second when it's not centered at the origin. All right? But -3, 0, if I multiply both of those by a third, I get -1, 0. 0, 6, if I multiply each of those by a third, I get 0, 2. And then 3, 6, if I multiply those by a third, I get 1, 2. So if your center of dilation is the origin, you can just multiply your coordinates by your scale factor. Okay? In the next video, we'll talk about example 3, where what if our center is not the origin? How do we find that? How's that going to work?